tells me, wow, take two. Welcome to the Device Dojo. I'm Joseph, and this is where we tackle the practical side of securing connected devices, from over the air updates and fleet management to the broader challenges like incident detection and response, compliance, encryption, and more. Always actionable and hands on, and brought to you by Northern Tech, the makers of Mender.io. Yeah, my hopefully cheesy intro video woke up everybody again. As you know, every second Thursday of a month, you get to enjoy or be pestered by my things I do about securing connected devices. And today I'm going to do something which might sound weird. I want to talk about multi factor authentication on the device. And what do I mean by that? Let's get started. First, the Device Dojo is a video series which is presented or sponsored by Northern Tech. They are the makers of Mender, Alvaldi, and CF Engine. I'm hosting this. You might know me already. I'm Joseph. I'm a developer enablement expert. And the Device Dojo provides the main series, which is this one, where we do, let's say, in-depth dives at an actionable item that helps you make more secure devices. But there are also alternative formats like office hours, just shorter tutorials, live coding sessions. It's really like a place to exchange about securing connected devices. What do we want to do today? First, we want to talk about why you actually want multi-factor authentication. Then we're going to look at a way to implement this on your devices. We're going to use PAM and Google Authenticator for this. Then we obviously need a generator for it, MintTOTP. And then we're going to do the on-device jump, and I'm going to give you a demo on what I mean. So first of all, why do we want multi-factor authentication? Michael said he joined after the music. Boring. Multi-factor authentication, you might know from your Gmail account, for example, where you have to type name, password, and something else. You log into something, and your device also must have a login. We usually call this a service login. You can have other names for it, like debug port, debug shell. It really doesn't matter. If your device has something where service personnel, developers, whatever, can actually log into, then this can be very, very useful because you can directly interact with the device, like for troubleshooting, adding specific configuration, managing the device, all of this stuff. And the usual ways to do this are either the local UART or mostly SSH. And this usually is just password and username. But those service logins are often very, very safety critical. Not only because you can access personal data or critical data, it also can be really physically safety critical if the device needs to be in a safe state before you start interacting with it. Because if you are on such a login, you, in the vast majority of cases, you actually have root access. So you can stop applications, restart them, do all kinds of stuff. And if your device does something like drive around or handle hot materials or large moving parts where people can lose fingers or more of their bodies, then you really should be sure that the device is in a safe state. But how do you know this if you are on a remote shell? This is what we're going to talk about. So first of all, multi-factor authentication is definitely a best practice. You know this, as I said, from your Gmail account, where it basically is semi-mandatory by now. It will ask you for an SMS, for example, if it doesn't know your mobile. And a lot of other services do the same. This changes, essentially, the scheme from username and password to a login to username and password and something which is usually called a one-time password for the login verification. So it does not have only one factor, it has two. Usually it's two factors, but it can be more. And this multi-factor authentication changes the mental model of the login from something that you know in order to log in, because username and password is something that you just have to know, or you write down on a post-it on your screen or whatever. It's something which is very, very easily transferable to something which you also need to have, because those OTP are, in the vast majority of cases, again, generated by either physical tokens, like those RSA key fobs that many of you probably know, or the others know, authentication applications on your mobile phones. Like there was Authy by Twilio, there's the Google Authenticator, there's Microsoft has an authenticator. It really doesn't matter. And those are not as easily transferable because they are tied to something very, very physical, either your mobile phone or the key fob. And Michael adds a third factor, something you are. It's very complicated to add being a jester into an authentication process, but it would be a very interesting proof of concept. I agree. Yeah, but I guess you're referring to biometric things. Yes, that's if you're talking about desktop things, that's definitely one of the current directions where things go. So my line of thinking is, why should you not use something like this for your service login into your connected device? So let's try and find out. Now we're getting to the technology. We're talking about connected devices running Linux, and Linux has authentication mechanisms. Primarily, it has PAM, the pluggable authentication module, where you can just like configure and stack different mechanisms to authenticate for your login. Turns out OTPs are just a form of authentication. So there is already a library for that. It's called Google Authenticator LibPAM, which is very close to the most stupid naming that I've ever heard of, because it has nothing to do with the Google Authenticator. It's a library or an addition, a plugin for PAM, which works with numeric OTPs. Nothing beyond that has to do with the Google Authenticator. It's written by Google or maintained by Google, but that's it. And this we want to put into our PAM configuration on the device. So what else do we need? I already mentioned it. We also need to have the counterpart where we generate the OTP. This might be the famous Google Authenticator now on your mobile, or it might be something else. In this case, we are going to use MinTOTP, which is it calls itself Minimal TOTP Generator written in Python. I selected this for a reason, and I'll show you in a second why. It's really, really simple. It's just a Python script that you feed the shared secret that is generated when enlisting the libpam. And then it gives you this famous 6-digit verification code that you need to use for login. But now you say, hey, that's not exactly super useful, because first I had to memorize username and password, and now I have to memorize username, password, and the secret. That's not exactly changing anything. So it adds secret management. Plus, it still doesn't keep me from doing anything harmful to the device. It's just another thing I need to do during the login. That is correct. So why not put min_TOTP directly onto the device too. And you probably are like, what, doesn't that defeat the meaning of the OTP? And I say, no. First, of course, in order to do this, you need to have a little bit of logic, which installs not only libpam, configures it accordingly, installs min_TOTP, and enlists it upon the first boot. So the secret is generated and stored on the device. I'm going to show you this in a second. The key is that now you actually need to have physical access to the device in order to obtain your verification tokens. Remember, the secret is now not leaving the device anymore. It's just on the connected thing that you have. There's no way you can generate a matching OTP using your mobile or to memorize it or whatever, because it will be invalid after 30 seconds. You just need to be able to interact with the device in order to get your verification code. And the key trick here is generate the verification code and put it on the display of the device, if it has a display. Because therefore, if you want to log into the device, you actually need to be able to see the display. Or you need to have somebody in front of the display who tells you the code. And then in your application, it's very, very trivial to say, hey, I'm just going to give you the verification code if I am in a safe state. Otherwise, I'm just not going to display it. Nobody can log into it. So now, by using PAM and OTP, we can enforce that somebody who wants to actively log into the device actually is able to physically reach it and interact with it and possibly put it into the desired state. And then we're going to do the obvious demo I prepared for this, which is not just the terminal this time. Let me rearrange my screen a little bit, because we need to see more things this time. Okay, no slides for you, but a screen. Here it comes. Let me see if I can still make this a little bit bigger. But in the end, it really doesn't matter that much. I'm just gonna build the image and run it. As always, I'm using QEMU ARM64 because it's my current go-to thing. It recreates the image. While it does that, I should click some fancy buttons here. Of course, remember to head over to hub-mender.io if you want to discuss any of this stuff, and I'm going to give you a link to the proceedings later, basically in 3 minutes, I guess. And I think that I can also click on that one. I always love that one. Like and subscribe. Yay. Okay, it's booting up. Mind, this is a full boot process, including UEFI and everything, instead of just simple run QEMU, because that's just my standard setup. And it says, yay, this is a restricted system. You cannot log in here. And I'm like, Mender? And it now tells me verification code. Where is it? I need to be able to see the display. In this case, it's VNC, obviously. And now I can hopefully really get into the system. Yay! That's what I wanted to tell you. Tying login credentials to something physical is good, but you need to be very careful to which thing you tie to. And you can actually use this to enforce real life things that happen in the physical world. Because usually you don't have a VNC connection, or if you have one, then you should make sure that it doesn't display the verification code, obviously, because that defeats the whole story. Let me get back to the slides for a second. So what did we learn and see today? We did learn and see that one more time, I took a lot of inspiration from Esa. So he gave me the starting point for using Google Authenticator and MintTOTP. I just like glued everything together into a Yocto build and auto enlisting, obviously. And you can find the link to how I actually did this on the Mender Up. Besides that, what should you take away here? If you have a device that can harm things and or people, ensuring the safe state is crucial. And how do you usually do this? By physically accessing the device. I advocate for making sure that this physical access happens, but I don't like reinventing the wheel every time and again in terms of, hey, okay, now let's write this magic for the login protection, blah, 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 blah. No, there's things for this. And PAM and OTP are well known, are well proven. So let's just use them for this. And that's the one thing I wanted to share today. The next session will be on December 11th, same time. I will also try to wake you up again. And for the first time, I'm not going to do something on Linux or Yocto. I want to talk about HTTPS and specifically S on Zephyr, because I personally ran into some interesting effects here, which I want to show you. And hopefully we can make something nice of it. With that, if there are no more questions and or remarks in the chat, I thank you for your attention. And as I said, hit subscribe if you don't want to miss out on the next session. Drop comments below whether you've got questions about what we covered today, ideas for future episodes. I always love to hear from you. You know that. If you're ready to implement OTA updates in your own projects, of course, check out Mender.io. The links are all in the description, and I hope to see you in the next episode. Bye-bye.